All right, so I'm not gonna go over the first two because you know how to simplify fractions. You can look at these if you need to. Next one, and then we're gonna move on. How the process is similar, you just cancel things. All right, so let's see, simplify the expression. So to simplify this, we would want to cancel out the things that are both on the top and the bottom. So those cancel out because x plus 3 over x plus 3 is equal to 1, and that leaves us with 3 times 2x minus 1 divided by x plus 2. Okay, so to simplify this, we just want to take out whatever we can from all the terms on the top, and then we same thing on the bottom. So I can divide both of these by 2, so I'm taking and x squared actually, right? I can take this x squared out. I can take x squared out of x cubed, and that just leaves me with an x. And then I can take the 2 out, and I can take 2 out of here. And that leaves me with a 7. So we get 2x squared times x plus 7. And then on the bottom, we will be able to factor out, let's see, both terms have an x in them. So we can pull the x out. This one will leave me with just x. And then both terms have a multiple of 3 in them, right? I can pull the 3 out here, pull x out, and I'll pull a 3 out here, and that leaves me here with 7. And once again, I've got x plus 7. So I took out 3x. And I was left with 2x squared over 3x because these cancel. I guess on this one, you just select this, and then it does that for you. So to finish it, you get 2x squared divided by 3x. Next one, which of the following are equivalent forms of the rational expression below? So the first step here is going to be to factor both the top and the bottom. The bottom looks easier, so I'm going to do that first. I've got x minus 4 times x plus 3. Negative 4 and 3 add up to negative 1, and negative 4 times 3 is negative 12. And then on top, we've got 2x, x. It's got to be factors of, it's going to be either negative 3 or positive 3. That's 6 minus 1 is 5. All right, so we've got that. And we can simplify this, right? X plus 3 cancels out, and we're left with 2x minus 1 over x minus 4. So let's see, this 2x minus 1 over x minus 4. And this one is what it looked like right before we canceled. This one is plus 1, so that's definitely not it. This one has x plus 3. Oh, that one looks like it might be it too. Because the x plus 3's are just moved, but they would cancel. 2x minus 1 over x minus 4. Oh, maybe that one doesn't count because... Oh, looks like I'm doing terrible. Oh, I canceled the wrong one. Okay. The reason this one doesn't count is because if you were to graph this, there'd be something called a hole, and we're not going to get into graphing. There would be a hole in the graph at x equals 3, whereas for this one it would be at x equals -3. So it does technically have a different graph, but we're not going to get that deep into this. All right, now we're getting into solving. So let's see. All right, so we're going to, first thing we do, step 1, factor this. Factor everything. In this case, we only have one thing to factor. X squared minus 7x plus 10 equals x minus 5 times x minus 2. Pro tip, usually just look at these. I'm not going to make you work extra hard, so that having those match up makes things cancel nicely. But you won't know that if you don't watch this video. And then, so that's, everything's factored now. So we've got 3 over x minus 5 times x minus 2 equals x over x minus 2 plus 1 over x minus 5. Okay, so now we're going to do our little trick where we basically our goal is to get rid of this denominator here to make the left side of the equation easier to work with, and what the effect of that is generally going to be is it's going to make this side easier to work with too. So to get rid of this denominator, we're just going to multiply by its reciprocal. So if this is 1 over x minus 5, 3 over x minus 5 times x minus 2, we're just going to multiply by x minus 5 times x minus 2. So times 3 over. So we need to do it by both sides, but what this does for us is nicely cancels x minus 2 with x minus 2, and it cancels x minus 5 with x minus 5 on that side. We don't really get any clean canceling right away on the other side, but we will. See the whole thing. X minus 2 is there. So we're gonna, so the left side just becomes, oh, forgot that. This just becomes 3 because all the denominators canceled, and then we've got this. And what's going to happen with this is it's going to get distributed to both of these terms because there are 2 terms in here. So now that that's been distributed, we've got x times x minus 5 times x minus 2 over x minus 2, and x minus 5 times x minus 2 over x minus 5. First thing we want to do here is now cancel terms. I actually want to go back real quick to this step because I just remembered something. We need to acknowledge that there are some x values that we cannot use, and eventually when we cancel things out we won't be able to see that anymore, but if it was true at the beginning, it's true always. So looking here, I know that x cannot equal 5 or 2 because you can never divide by 0, and again, even after things cancel out, that does change things. So now that we're back down here, that won't come into play till the very end, but now we're back down here and we've got 3 equals x times x minus 5 plus x minus 2. We can expand the x here, so multiply that times that and that times that. And now we want to move everything over to the right side so that we have 0 on the left side, so we're going to subtract 3 from both sides. We can combine like terms because we have 2 x terms and 2 constant terms. So now we have x squared minus 4x minus 5, and we can factor this. X and x, and then multiplies to -5, adds to -4. That's going to be x minus 5, x plus 1. And then you get x equals -1 and 5. But wait, remember earlier we said x cannot equal 5. So that means that's an extraneous solution, and we need to cross that out. So then x equals -1. So this next one is very similar to the last one. Exact same procedure, just with different numbers mixed in. So the first thing we're going to do, once again, I'll try and write out the whole step-by-step process here. First step is factor everything. So once again, these factors just coincidentally happen to be very similar to those numbers. And then now we also want to say, like, this is where we want to say x cannot equal 2 or 6. Because if I plug those in, I'm going to get 0 right now. And that's going to be true at the end. So we got to check. Once we get our answers, we'll check and see those aren't our answers. All right, so number 2, our second step is going to be get rid of the denominator. This is going to look different depending on the problem. In the next problem, it looks a little different. On this one, it's the same as the last one. But basically, you just need to use your understanding of algebra and your knowledge of how to move things from side to side in an equation, how to cancel denominators, all that stuff you've learned in the last few years of high school or math. You're going to need to pull those skills in because it's not always going to be exactly like these problems. The problems are different. So it's going to be, we're going to multiply both sides by k minus 6 over k minus 2. Sorry, k minus 6 times k minus 2. Okay, so these cancel, right? And then on the left side, we're just left with 4. And on the right side, we need to distribute to both of these terms. And that's going to give us... All right, so now we've distributed. We can do some canceling before we move on. K minus 6 and k minus 6. K minus... Oh, did I do that right? That was supposed to be 2. This one's k minus 2. Oh, actually... Okay, this one's k minus 2. There we go. All right, sorry about that. Now we've got that cancels and that cancels, and now we can write this out in more simple terms. So we've gotten rid of our denominators. This became a much more easy to deal with problem. I want to distribute this right here. It's k so that I don't have to deal with this. This can just lose its parentheses because there's no coefficient. So this becomes... And we're going to move the 4 over to combine like terms and set it equal to 0. So we've got 0 equals k squared minus 5k, negative 6k plus k, and then minus 6. And factor that. We get k minus 6, k plus 1. So then k equals 6 and negative 1. And then let's look up here and see which one. So look. X is not allowed. This is supposed to be k, not x. K is not allowed to be equal to 6, which means k equals negative 1. And on to the next one. All right, so this one's a little different than the other ones, and that's kind of what I was pointing out in the last part of the video, that they're not always going to look the same. You just need to have kind of an arsenal of tricks that you know about doing algebra. With this one, first thing I'm going to do is factor. I know, and I'm kind of talking through. I hadn't done a problem like this in a while, so my thought process when I approach this. First thing I want to do is I see this and I see it's hard to work with, so I'm going to factor it because that'll make it easier to work with. So then I'm going to get, all right, so now from here, again, I still don't know exactly what to do, but it looks a little clearer. What I'm noticing is that these two things do have a common piece of their denominator. So if I were to make these two have the same denominator, it would make it easier to combine them, right? So that's what I'm going to try and see if it works. And that was kind of my thought process with this. So to make these two have the same denominator, I'm just going to multiply this term by x minus 2 over x minus 2. I can do that because this is equal to 1. And so I'm just doing it with this term. And what that's going to do is it's going to give me a denominator that matches this one. So I guess what I would call this step is like match denominators. So that leaves me with 1 equals 1 over x times x minus 2 plus x minus 1 times x minus 2 over x times x minus 2. So now I have matching denominators, and I can say, well then 1 equals 1 plus this, and I can come. And that doesn't immediately make things better, but what I can do now is if I multiply both sides, if I have a denominator and I multiply both sides by that denominator, it'll get rid of the denominator. So then I can have much more freedom because denominators always make things sticky. So to get here, I basically just canceled this whole denominator with this and then multiplied it on the left side. So now I've got nothing with denominators. I'm going to expand these out and see if maybe it gets me to a point where I can set one side equal to 0 and then factor. So now I actually see that the x squared is the thing that requires you to factor, right? Well, what I see is I could just do minus x squared on both sides, and all of a sudden I don't have x squared to deal with. I also could do plus 2x here and get rid of that right off. So what do I have left? I have 0 equals 1 minus x plus 2. Then I'll just add x to both sides. You get x equals 1 plus 2 is 3. And so there's only one answer. That one was actually nice and clean at the end. And that's it.